Corridor objects can be some of the most complex objects in Civil 3D. The reason is that all the other objects we have created up until now will link to the corridor. Any changes to those other objects will require that we rebuild the corridor and update it so that we can see the design. Corridor objects are very flexible objects. For instance, if I zoom in here, I have something called an offset alignment already created. If I change any aspect of this offset alignment as it is being used by the corridor to model, it will require a rebuild unless you have Rebuild Automatic turned on. I'll go ahead and just pick this, and then I'll just modify its offset. Notice how the corridor object is requiring that I rebuild it. I'll right click on here, select Rebuild, and notice how it rebuilds the corridor with that update. Again, very powerful, very cool functionality. One of the other things I have in this drawing is an AutoCAD 2D polyline. But what's really unique and cool about this polyline is that I'm using parametric constraints, just regular AutoCAD parametric constraints to constrain this object. So it'll actually maintain tangency, use coincident points, etc. Any changes to this AutoCAD polyline will update the corridor object as well. So as far as the settings and styles specific to a corridor object, there are some settings and styles for the corridor object itself. However, the majority of the settings and styles will actually come from different locations, such as the code set style, a surface style if you created one, and so on. So as far as the style for the corridor, if you go to the corridor category, here are the corridor styles. However, this just contains some basic information. It will not actually change the display, as you see here, of the corridor. This is actually being defined by the code set style. Again, the corridor object is very powerful. I'm going to select this and change this to a simple new code set style called visualization. Notice how just like that my display has changed to just show the linear work. Well, let's go ahead and take this object now, the corridor object that is, into my object viewer. I'll select it, right click, object viewer. And just like that, because of the code set style and because of the automation, I can create some really cool and awesome designs and see them in a visual way. Press escape to exit the object viewer. You can also automate quantities. We will discuss quantities in greater detail, but let's just quickly look at how I can easily, using a quantity pay item file that's already been defined in my file, compute some quantities that I've defined by the code set style. Just like that, I now have the pavement quantity and the sidewalk quantity. I can take that into Excel or save it out as a text file. This concludes this video discussing an overview of corridors. So let's talk about creating corridors. To create a corridor, go to the Home tab, Create Design panel, select the Corridor tool. In the Create Corridor dialog box, you define the settings and parameters you want to initially use to create your corridor. First, let's give it a name of Bypass-1. We'll pick a style, but don't forget this style actually does not control the actual display of all the different parts of the corridor model itself. That is defined by the code set style, which we will talk about later on. As far as the corridor layer, that's coming from the object properties in the drawing settings dialog box, so that's why it's automating the layer name suffixed to the layer. We have the alignment that we want to select, and then of course the profile, and note how the name of the profile is with an underscore because that brings it to the top of the list. Should you forget to choose it, you're guaranteed at least that you're using the proposed profile. Select the assembly you want to use to model, and then you can target the surface to daylight. If your assembly does not contain any daylight subassemblies, you will not be able to target any surface. You can leave this toggled on to set your baseline and region parameters after you create your corridor, or you can toggle it off and the corridor will begin creation. Let's go ahead and leave it on and click OK. We are now prompted and allowed to change or define any of the targeting. In this case, all I want to do is simply set the appropriate start and end station so that we don't get any erroneous corridor modeling. Let's just go ahead and first define the starting station where our vertical alignment is. This is 3 plus a pair, or 300. And then for the end station, I will select the pick button here to define the ending station in our drawing. So what I'm going to do is I'm going to go ahead and zoom in to the location of where the ending of our horizontal alignment is located. You can also define the frequency. If I click on that, I can define how this corridor should model when it goes along tangents, curves, spirals, profile curves, the horizontal geometry like PCs, PTs, and so on, super elevation critical points, the profile geometry like PVIs and PVCs and PVTs, as well as the additional ones located below here. You can also add your own stationing if you want to. I'll click OK with the defaults, and then click OK, and you're notified to rebuild the corridor, and of course we will rebuild the corridor. And just like that, we now have our corridor model. So as you can see, it's very easy to simply create the corridor model by picking the horizontal, vertical, and assembly. This concludes this video discussing creating a corridor. Civil 3D allows you to target almost any kind of AutoCAD or Civil 3D object with subassemblies. As long as the subassembly is allowed to target, then you can define that target in the corridor model. As you can see in this drawing, we have two model space viewports open. One shows the top or plan view, and the other one we have a 3D type view so we can see any of the changes that occur when we do any kind of target mapping. The first step to target mapping is to select the corridor model, and in the contextual ribbon, we'll select the Edit Targets option. You are prompted to select a region that you want to edit the target mapping from. In our corridor, we only happen to have one region. But what's great about this functionality is that as you hover over the corridor and the different regions within your corridor model, you can actually then visually see which region you are going to be editing. I'll go ahead and click. So the first thing I want to mention is it is key to name your subassemblies something that makes sense, especially as it relates to the right or left side of the alignment. Right now, in this dialog box, there is no way to actually select a subassembly that you want to choose to target with. You can only see the name of the subassemblies and what they can actually target. So going down the list here, you'll notice, of course, we have the daylight subassemblies, which of course can target a Civil 3D surface. Then, as you notice here, there are other subassemblies that can target a width alignment, as well as additional points within the subassembly, like this inside boulevard for sidewalk, or the sidewalk width, or the outside boulevard width. In addition to targeting the width, you can also target a slope or elevation target. We can do an elevation profile for the different subassemblies listed here. Again, depending on how you created your assemblies with individual subassemblies, this will decide whether or not those subassemblies can actually target anything. The first one we're going to target is our sidewalk. We want to have the inside boulevard width on the left side target some 2D AutoCAD objects. What's great about this functionality is that within this file, I'm actually using 2D AutoCAD constraints to define my geometry. So I define the actual inside boulevard width using constraints like tangents and concentric constraints, and any changes I make to those standard AutoCAD objects will automatically update the corridor. It's a really great feature. We'll click on the object name column, and now we'll select the appropriate object type to target. Notice that you can do alignments, which we'll do next. First, we'll do the standard AutoCAD 2D polylines. Note that you can also do feature lines and survey figures. Note the option to either select from the drawing or select by layer. So in this case, we'll select from the drawing. When I click on that, it minimizes both dialog boxes, and then I'm prompted to select objects. I'll go ahead and select the 2D polylines that I have in my drawing. What's nice is these objects do not actually physically connect. In other words, I've got one object defining a boulevard in this location, another object defined in this location, and they are not connected in any way, shape, or form. AutoCAD Civil 3D will automatically target just when it sees those objects. It knows automatically where they follow along the stationing of the alignment. Not shown here, but one thing to note, you can also target objects in X references. This functionality was added in AutoCAD Civil 3D 2014. So if you're using anything before 2014, you will not be able to use this functionality. That makes targeting even more powerful, as you can have all the objects in an XREF file, and then any changes in that X reference will update automatically in the corridor model. Press Enter to finish my selection set, and notice the two polylines that appear. I'll click OK. And the next thing we want to do is we want to target the right lane with an offset alignment. So there's already an offset alignment created in this file for our tapering of our transition lane. We'll go ahead and click on here, and we'll set the object type to target to alignments. And I could select in the drawing, but because I named it already, I can just say bypass one right 12 feet. Click Add, click OK, and then click OK again. I have Rebuild Automatic turned on, and as you can see in our 2D and our 3D view, the targeting is automatically occurring. This is fantastic functionality. Here's my inside boulevard width on the left side, and on the right side, as you can see, it's targeting with that offset alignment. Again, one of the most powerful parts of this functionality is that Civil 3D will update automatically when you change any part of those objects. So I'll go ahead and select this 2D polyline. Again, notice the 2D constraints here. And if I just go ahead and do some minor edit right here, we'll just rebuild it here. will update automatically. Just really powerful functionality. This concludes this video discussing target mapping.